Unit 2, Lesson 5. We're going to do 5, 6, briefly 7 and 8, and then that's pretty much it. So just keep that in mind. We're coming down to the end of the section like I told you would. So yeah, we'll talk about tests and stuff off camera. But so the main idea is understanding that we've gone from translations, left, right, up, down movement, to reflections over x and y axes. And now we're doing the shape of the graph actually changing in terms of stretching. We're going to stretch it horizontally and vertically. Okay, so we're going to look at both of those today. So just looking at this first one, we're looking at the form of a f of x. So that's multiplying the whole function by a number. Okay, and so the first one they did is 3. Okay, so we'll rewrite the equation. So the equation here, we can't distribute that into the radical or anything. So all this is going to be is 3 times root 4 minus x squared. Okay. If you have a graphic calculator, you can do that. I'm going to do the first couple of the graphic calculator, and then so we can go a little bit quicker in the video, I won't. But I do have them put in already, so this is going to go away. If you need that equation, I'll wait another 10 seconds, and then I'll put the calculator on. Okay. All right. So okay. So, sorry, I was clearing this out real quick. Did something for Math 20. Okay. So here's the original, and then here's the one we changed. So we're just going to go turn on that bottom one so that we can get it turned on. All right, now we're ready to go. Sorry about that. So there's our 2. Oops, I have a third one in there. Sorry, third one is down here. This guy's on, sorry. All right, now we should be fine. All right, so there's our 2. And so you can see that it did stretch. My window needs to be extended a bit here, so I just need to extend my window. We'll just make the y max 10, and we should be able to see everything now. All right, so they do break in the graphs just because they're getting really tight to each other, but they are going to finish at the same spot. That's important to understand. So here, this is the, right here is the original, right there, and then this is the new one. So pay attention to what changed. The y changed, right? But the x did not. They are finishing here together. That's important, okay? The vertical stretch did not move anything within your x-axis, okay? Any questions with that? Okay, so, well, what did it change by? Well, this is going through 2, and this is going through 6. Well, that's not something that we wouldn't expect, okay? It essentially changed it by a factor of 3. Okay, so all this stuff is pretty straightforward. I'm just going to draw the one we just had here. So it's up here at 6. So it looks something like that. Describe the number 3 in the function, how it affects. So it affects it by a vertical stretch factor of 3 about the x-axis. Kind of like a way. It's like about the x-axis, so it didn't flip or anything. The x-intercepts stayed the same. The y-intercept went from 2 to 6, so it was multiplied by a factor of 3. Okay, so this lesson's a little bit slow in the sense we're going to really go through these thoroughly, probably a little bit more than we need to. Okay, so let's say, I'll do the first couple graphs in the calculator, and then we're going to speed it up a bit. Okay. All right, so then conversely, if we look at 1/2 f of x, okay, well, what do we think that does? Yeah, I think it's going to shrink it. Well, let's write the equation. We'll write the equation second this time. It's already in here. You guys kind of know what it's going to be. Where's it at? There it is. Okay, and then we have it right here. Turn that off. Turn that on. Okay, and so this time it's underneath the original. So it did get smaller. So it went from right here, we have, you can see our y-intercept is 2. This time it's 1. Okay, coincidentally, that's half the distance. It's half the factor. Okay, again, they have the same x-intercept. That's important. The vertical stretch maintains the same. Okay. All right, so then if we go ahead and we go back to, gosh dang it, I don't know why that does that. Oh, there we go. Nope. Sorry, I'm not sure why this thing highlighted blue sometimes, but okay, so let's write that equation real quick. So the equation simply is y equals 1/2 square root 4 minus x squared. We already used the graphing calculator to do that. It's going to go through here at 1 and just be a little bit smaller. So it shrunk a bit. So the general sketch of y equals f of x, it's a vertical stretch by a factor of 1/2 about the x-axis again. Okay. X-intercepts, same. Y-intercept went from 2 to 1, so it was a multiply by 1/2, or factor of 1/2. Okay, so we're just going to finish up the vertical stretch here. Complete the following statement using the results in parts 1 and 2. Compare the graphs of y equals f of x and y equals af of x. Results in a vertical stretch about the x-axis by a factor of a. This is the straightforward one. Vertical stretch is pretty simple. If you remember parabolas in Math 20, if you had a 2x squared, it made it steeper because it times it by 2, so it was a little bit steeper parabola. Same rules apply here. The horizontal stretch is a little bit different. There's just a little flip, so we'll talk about that now. Okay, so the last one I'll use the calculator for here. So if we go into, first off, we do want to write the equation because a lot of times people mess this up. We're putting 4x in for x. So that means the 4 is being squared as well. A lot of people just put on the x. So when you rewrite this equation, it's now this. 16x squared, right? You got to square the 4 and the x. So just like before, when we talked about horizontal translation, you're subbing something in for x. Now we're talking about horizontal stretches, you're subbing something in for x still. So we subbed in a 4x for the x there, and it gave me 16x squared. How does that affect the graph? So we'll go look at that here in a second. I'll pause the video. So if we go to, let's go down here. Let's get the calculator back up. Okay, let's turn off the vertical one we just did. Okay, let's turn on the one we just made. So look and see what happens. So that's the one that was up there before. So what's going on there is that you can see, what do they share this time? I know I'm going to tell you the lines do finish. So if you're saying, wait, what happened? Why isn't it finished? It does continue down here. It's right there and hits right there, about 1/2 and -1/2. But let's notice, make observations. What didn't change this time? The y-intercept. Yeah, see, the y-intercept stayed locked in. And now we had a stretch in, right? And so the weird thing is, if you're saying, wait, it was 4 though. 4, intuitively, what would you think would happen with a 4? Yeah, it'd get bigger, but it didn't happen, did it? It got smaller. That's the change with horizontal. Instead of thinking 4, think about divide by 4 or 1/4. So it was 1/4. So check this out. This right here is at -2, right? This is at -1/2. 1/2 is a quarter of 2, right? You think about that with your fractions? Think about it this way. 1, 2, 3, 4, right? So that it went there, there, to there. So it was essentially divided by 4. 2 divided by 4 is 1/2. We got to -1/2 and +1/2. So yes, that's how we got there. Okay. Okay, so let's go ahead and do this part here. So we'll sketch it in here. It is right here and right here, and it still goes through the 2 right there. That's what the picture looks like. So the general sketch creates a horizontal stretch. Okay, horizontal stretch about the y-axis by a factor of 1/4. Again, because it got smaller, I know you think, wait, it was 4. Yes, it's 4, but the factor that it stretches is 1/4. The x-intercepts, do they change? Yes, they change from -2 and 2 to -1/2 and 1/2, which is they are multiplied by 1/4. The y-intercepts, same. Okay, 2 went to 1/2. Okay. Okay, any questions? Okay, we'll finish this one here. So the 1/3, what do you think's going to happen with the 1/3 then? It's going to get bigger, right? Because 1/3 flipped is 3, so it's going to actually be a stretch of 3 this time. So you're seeing that at the horizontal holds the fact that it's 1/b, which we're going to get to in a second. Okay, so yes, you're right. So the 1/3 x, if we plug that in though, let's look at 1/3 x. That's going to give me square root 4 minus 1/9 x squared, right? 4 minus 1/9 x squared. Where do I get the 1/9? Right, it's 1/3 squared. 1/3 squared is 1/9. Okay? So I told you it's going to, this time it's going to be a scale of 3. So if it's at 2, where's it going to be now? It's going to be at 6. And it's going to be at -6. And look, it's going to be this big arch because it's going to still have the same y-intercept. That's pretty good. Okay? So that's what it's going to look like when you put in your calculator. Describe what happened. Horizontal stretch about the y-axis by a factor of 3. Okay. The x-intercepts did change. The x-intercepts went from -2 to -6 and 2 to 6 multiplied by 3, and no change on the y. Okay. All right, just got enough there so we can finish that last couple spaces. So it says complete the following statement using the results from parts 1 and part 2. So we're finishing up horizontal stretch basics. Compare the graph of y equals f of x. The graph of y equals f of bx results in a horizontal stretch about the y-axis by a factor of, this is 1/b. Obviously, you can see that in your paper. Mine's just a little bit not quite up high enough. But 1/b, so it's a flip of what you see. Okay, so what if you had 2/3? What would your stretch be? 3/2, right? If you had 5, it'd be 1/5. So 1/5 would be really tiny, right? Be very skinny. Okay, so the bigger the number there, the skinnier it's going to be. And we'll see that with sine and cosine curves later, how it makes your sine and cosine curves shrink. Okay, all right, so let's look at this one. Now we're looking at an actual graph. So we have, write the equation which represents -3 of that guy. So we're just going to multiply -3 to all of it. So that just is going to give me plus 6x squared plus 15x plus 6. So I do the -3 and that's what it gives me. And we're going to go ahead and skip the graph calculator part here. And we're going to start getting better at using our graphs. So if this, what type of stretch is this? Yeah. It's a -3. Oh, that's, yep, we do. Thank you. I just didn't want to change the sign for some reason. Yep, minus 18. Thank you. Okay, so negative 3x cubed plus 6x squared plus 15x minus 18, excuse me. But we want to work on doing this in terms of, you can put in the graph calculator to get an idea, but the graph's here for you. We should know how to flip this. So this is negative 3. So it's not only stretching, it's reflecting, right? And so that's from your quiz you just had. This will be a reflection over the x-axis and stretched by 3. Okay, so we have to do both those things. Now, the thing I want to point out is we know, though, what's not going to change with a vertical stretch? The x-intercepts. These are anchored. They're not going anywhere. That's going to be part of my new one as well. Right? Okay, so find some points that you can do. Like, let's do this point. We're going to change. I mean, as we're going to flip it. Let's do that point. We can do that one. We can do that one. And let's do this one. I don't think we'll be able to do that one, actually. It's too big, but it's okay. All right, so let's just take a couple of those, and what I'm going to do is I'm just going to go through them. So this point right here is negative, what is that? Oh, okay, that's negative 2.5. Okay, negative 2.5, but that's not important. The important part's the y, because all this is happening to the y, right? Negative 3. So it's at negative 10. So what is that flipped? 10, and then 10 times 3 is 30. So that's going to be just up here off the page a bit. Okay. And then let's look at the point I have here. Negative 1, 8. So 8 flipped is negative 8. Times by 3 is negative 24. So that's where that one's at. This one here, that is 6. So flipped is negative 6. Times by 3 is negative 18. So it's right there. 2 more. This one's going to be too big, actually, so 1 more. So this is negative 4. Flipped is 4. Times by 3 is 12. All right, so we have enough dots now to kind of see what it's doing. It's coming way up here, coming down like this. That and out of here. So that's what it looks like and when you sketch it. Okay. Any questions of that? Flipped and multiplied by 3. We just kept doing that to all the points we could find that were clean. Okay, we flipped them from positive to negative or negative to positive and multiplied them by 3. Okay. So describe what happened. So what happened is that we had the general sketch of y equals f of x was vertically stretched about the x-axis by a factor of 3. It was reflected over the x-axis. Those are the two things that happened. We noticed again the x-intercepts, there was no change. The y-intercept was multiplied by 3 and flip sign. Okay. And again, there's going to be redundant here. Compared to the graph of y equals af of x, results in a vertical stretch about the x-axis, the reflection on the x-axis. Okay, so we're going to do a horizontal stretch. We're going to look at a table that's kind of helpful for just your notes, and then we have a couple examples, and then we'll probably call it good today. Okay. All right, so we got the horizontal stretch example now. So instead of doing a vertical, you can see they stretched it for us already. And they stretch it because this is going to make it what? 1/3 makes it Yeah, wider, right? By 3 because we're going to flip it. And it's also a negative, so we're going to have a flip there as well. What's that going to flip over, though? The y-axis. We're flipping over the y the whole time now. Okay, so let me show you what I mean. This right here flips over the y-axis because we're flipping our x's, okay? And we're doing it, stretching it by a scale of 3. So for example, our x-intercepts now do change. So those are good landmarks. Okay, so let's use these landmarks. So this 3 is now going to be a negative 3 times by 3. There. Okay, maybe I should go different color for the new guy. So let's go green. So they're right there. Negative 2 flips to 2 times 3, 6. 1 flip to negative 1 times 3, negative 3. That's my new x-intercepts. Let's find a couple more points that we can steal here. Let's steal this guy. That guy's not going to do anything, right? Y-intercept stays the same. Okay. This guy. Maybe those two will be good. So we know y-intercept stays the same, so we can just go ahead and mark this green. This is at negative 1. So this same height's going to be at 1 times by 3. So times by 3 would get me to 3. Right there. Okay, and this one down here I have, this is at 2. So 2 flipped is negative 2 times 3 is negative 6. So this is what your graph's going to look like. Went to that. Okay. So you can see it's definitely been stretched out. It's definitely not as steep anymore. Okay. So we write the equation. So if we want to write this equation, which we haven't done yet, sorry. The equation would be, we have to put in the negative 1/3 cubed, and then we have the minus 2 times negative 1/3 x squared minus 5 times negative 1/3 x plus 6. And then when we simplify that, negative 1/3 cubed is negative 1/27 x cubed. Negative 1/3 squared is 1/9 times a negative 2 is negative 2/9. Negative 5 times negative 1/3 is 5/3 positive. And then plus 6 would be that equation. We just did B. Just to use a graph calculator, we did it ourselves. Okay. Any questions so far? Doing okay? Okay. So then, let's finish this out then. So the general sketch here of what we just did there was a horizontal stretch. About the y-axis by a factor of 3. Okay, and then we had a reflection over the y-axis. The x-intercepts did flip. The x-intercepts went from negative 2, 1, and 3 to 6, negative 3, negative 9. So they were multiplied by 3 and flipped. Y-intercept, same. Okay, so we can compare the graph y-axis of x, results in a horizontal stretch by the y-axis and reflection on the y-axis. All right. anything? Okay, so here's just this table that just kind of puts it all together, what we've done. So we have kind of one thing I want you to add to this table that I think they should have is see how it says between 0 and 1 for A? So if A is between 0 and 1, that's kind of like smaller or wider the stretch is going to be. It's going to be kind of out more, okay? And when it's bigger than 1, it's going to be steeper. So see how this black line is steeper than the original? This one's wider than the original. Okay, just something to think about in terms of what they're doing. But they're both, either way, they're both vertical stretches by a factor of A about the x-axis. Same thing here. Okay. There's a little bit of misprint on this one. Or wait. Oh, no, it's reflected. Okay. Misprint's coming. Okay. Then when A is less than 0, so if our A happens to be negative, then we know it's reflected in the x-axis and stretch vertically about the x-axis. Sorry, that's pretty bad. That says steeper. Okay. All right, so then the second piece, the B's. So I'm talking about the horizontal piece. So you kind of see where the misprint is there. This right here should be y equals f of bx. That's what we're talking about now, just like it's down there at the bottom. So the graph of y of fx would be stretched horizontally. And then this one's between 0 and 1, so that's going to be a growth, right? Grow or wider, right? Because 1/2 flipped is 2, 1/5 flipped is 5, okay? By a factor of 1 over b by the y-axis. The 1 over just means the flip. And the b bigger than 1 is going to shrink it, smaller, stretch horizontally by a factor of 1 over b about the y-axis. Okay, and then when your b is less than 0, it's going to be reflected in the y-axis. All right, let's do a few examples here. All right, so we got the basics down. Okay, so you have that down, that's good. This is just kind of reviewing what we just talked about. Okay, so I think you're fine. But let's look at these. Let's go. You guys chime in. Let me know what you guys think the answers are here. So write a replacement for x or for y in the equation of y equals f of x after each transformation. So they say it's a horizontal stretch by a factor of 6. What would that be? How would you write that? Horizontal stretch by a factor of 6. How would you write that? You want to try, Hannah?
I'm not sure if it's 1 over 6 if it's horizontal or if it's vertical.
So horizontal is the one that you flip. Vertical is what you see.
Vertical stays the same.
Right.
Okay, because I was getting confused.
Right.
Yeah, so that one.
Right. So it should be this. Y equals f of 1 over 6x. So we put 1 over 6x in. That gives you a horizontal stretch of 6. Right? The horizontal is the flip. Okay? Vertical stretch by a factor of 1/5. What would that one be? So it would be that, right? 1/5 f of x. Okay. A reflection in the x-axis and a vertical stretch about the x-axis, a factor of 3. So we already did this one today. negative 3f of x. So the negative 3, it tells you reflection of the x-axis is important because that's telling you that it's going to be happening to the same thing for the vertical stretch. See how they're both happening within the x-axis? So that means they're similar in their spot. So like, what if I switch this to reflection over the y-axis? What would you have to change? It'd be a negative x in here now, right? Okay. Horizontal stretch about the y-axis, factor of 1/2, and a vertical stretch about the x-axis, a factor of 1/4. So you got two now, a vertical and a horizontal. Okay, so who thinks they can do this one besides Hannah? What's it going to be? All right, well, let's just take it one step at a time. Where does what do we do with the horizontal stretch of 1/2? What would that mean? You would flip, and where would it go? Right, it would go inside, right? 2x. And then the 1/4 is the easy one. Goes out in front. Okay. All right, last group here. Don't be afraid to participate. Okay, how's the graph of 3y equals f of x compare to the graph of y equals f of x? Well, don't get confused in this one. It's simply just divide that over, right? And that's the same thing as 1/3 f of x. So then what is it? It's a vertical stretch of 1/3 about x-axis. Okay. Now we're talking about what happens if we do this. So if we have the function y equals f of x, what happens if we put a 4x in? Horizontal stretch of? No? 1/4. Good. Horizontal stretch about y-axis. Okay, good. Replace y with 1/3 y. So if it's 1/3 y, it's kind of like this one, but it's 1/3. So then what will we do to it? Yeah, you could say flip it, but you'd multiply a 3, right? So you multiply a 3 over, so now it looks like this, and now we can see it's 3f of x. So that's a vertical stretch of 3 about the x-axis. Okay. Replace y with 6y and x with 1/3 x. So we're doing two things now. Okay, y with 6y. Okay, so it's going to be 6y equals f of 1/3 x. So I'm simply going to divide the 6 over so I can have everything on y equals form, which is the same thing as that. Shadow gets in the way sometimes, sorry. 1/6 f of 1/3 x. So we clearly see the vertical stretch is 1/6. So I'm just going to put v dot s for that. You guys know it's about the x-axis by now. Vertical stretch is 1/6. Horizontal stretch is 3. Good. Flip it, right? It's 3. Very good, very good. All right, we're just going to do this little graph here and be done just in time. Okay. All right, perfect. All right, so this guy here, we have sketch y as f of negative 2x. So here's the original, and we want to sketch the negative 2x of that. So what am I asking you to do? So what is your movements? What is happening here? So first of all, horizontal or vertical stretch? If you don't know that answer right now, then you need to ask a question, because that means you're behind. Horizontal, right? It's a horizontal stretch because it's in the f function of x part, right? Okay, good. Now with horizontal stretches, we have to flip. So is it getting tighter or wider? tighter, right? It's going to be a horizontal of 1/2. Okay? Is it going to flip? Yes, it's going to flip over. Good. Okay? So that's what we're doing. So what you kind of want to do here is you just do out the points here. So we know it's a horizontal stretch. So it's a horizontal stretch. That means that we are going to look at, like, if it's a horizontal stretch, we want to look at the x-intercept. That helps. So this is -6. So I need to go to +6. And it's half of that, right? So it's at 3. This is 5. Flip to 5, to -5. Half of -5 is 2.5. I just did the x-intercepts real quick. So these x-intercepts went to there. Does that make sense? Okay, I'll just keep doing these dots they have for me. This right here, -4, flips to +4. Half of that is 2. What's going to happen with this one? Stay the same. Good job. This one, +4 to -4. Half of that, 2. So there it is. So it looks a little bit different. Comes up like this, comes like this, and then it falls off like that. Okay? Any questions? Or technically, sorry, it doesn't fall off that. It just stops that dot because this dot stops. Just stops there. Okay, all right, very good. All right, we'll stop there.